Hi. So the Holoflector is a slightly different take on augmented reality or superimposing graphics on the real world. What we're looking at here is a large translucent mirror. Now you guys have probably seen setups where you have an LCD panel with a translucent mirror right up on top of it, and if you render graphics on the LCD panel, you can see that through the translucent mirror, right? So people have been making fun bathroom mirrors, for example, using this technique. This is a little bit different. What we've done is put the LCD panel 3 feet behind the mirror, and then we can render graphics onto that. And what we get for that is the ability to render graphics and make it appear as if it's perfectly registered with our reflection, if you're standing at about the correct distance away from the display. So I'm 3 feet away from the mirror, and the LCD panel is about 3 feet away from the mirror. And so basically the real image, that is the graphics on the LCD, is at the same distance as my reflection, about 6 feet. So there are a couple advantages. Like I said, we don't need gaze correction, quite like the rest of these demos do, because if you work out the trigonometry, it all just works out such that graphics that's rendered there will come, if it's rendered life size, will appear to be overlaid. And then also you'll notice that the focal distance is about correct too, because those graphics really are 6 feet away. So this is some of our investigations into overlaying graphics onto the real world using the Holoflector. This is basically right now we're showing the mesh from the Kinect camera overlaid. Just gives you an idea a little bit of some of the precision and the data that we're getting off of Kinect. We can also overlay the skeletal tracking data. So you'll see this is kind of a nice way to visualize what Kinect does, and probably in a way that you haven't seen quite before yet. Now you notice there's this blue sphere that's on my right hand. One of the things that I've done with the Holoflector is a little bit different, is play with the integration of the mobile device with the display. It's a little bit different. So you'll notice that as I move my phone from one hand to the next, the position of the sphere updates. I have to wiggle the phone a little bit. What we're doing is a little bit of sensor fusion. Right, so taking the data off of the accelerometer on the phone, comparing that to the accelerations that we see in the Kinect skeletal tracking data to infer where the position, where the phone is, who has the phone. And so let me show you a few things that we can do with that. You're having fun, that's good. and so it is inherently a multi-user thing. That's one of the advantages of not having relying on gaze tracking, right? So the view for you ought to be correct as well as for me. So here's just kind of a fun little thing, the idea of, if in the future maybe I can place a little holographic phone call, and so this little Kinect recording appears over my phone. As I move my phone around the position of this updates, I can also perform various manipulations using gestures on the phone. I can make it a little bit larger. Now this is simply a Kinect recording. I'm playing this back from disk. You can imagine that this would be an actual live image of someone, on the network. And then I can also, using the Kinect skeletal tracking data again, pass that off to my other hand. And if somebody else wants to come up here, I can pass that to them. Somebody? Anybody? Yeah, go for it. And so if the Kinect can pick you up, there you go. There you got it. I still have the ability to rotate and size me, but there you go. So sort of a very interesting idea on the future of telephony, maybe.
Were you tempted to make the model Princess Leia?
Of course, yes. Yes. Maybe I'll strap some cinnamon buns to my head and be done with it. Might be easier. So another sort of another example of combining the mobile device with the display is this one. So here we have. I'm going to basically maneuver this into position. So you notice that I get the orientation of this paddle from the phone itself using the accelerometers, and so I'm just trying to keep this ball in the air as long as I can, and I can catch the ball, I think. Yeah, there we go. Whoops. And so it feels like that ball is more or less in my hand. For me, it's in the correct focal distance in the right position. Now again, this is an effect that is a little bit sensitive to how far away you are from the display, so I encourage you to come up and take a look yourself. So this complementary nature of the mobile device with the display is nice, right? The phones are really very fast and give you good orientation information, but we don't get good orientation information from the hand yet with Kinect, and but we do get good absolute position from Kinect. So there's this really nice interplay between the Kinect and the mobile devices, and that's definitely something that we look forward to exploring more. And this I'm just showing just a fun sort of physics demo. Once you sort of start playing around with physics simulations and some of the gaming physics engines, it's kind of hard to stop. It's just so much fun. So just fluid simulation, very simple fluid simulation coming down.